Lesson 46, Using STL Strings. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. So far, we have gone over char array strings and wide char array strings. These were the first types of strings in C++ and were carried over from C. In this lesson, we cover STL strings, where our strings will be objects instead of just arrays. STL strings were created as part of C++ and are much more powerful than simple array strings. First off, we point out that there are two types of string objects. There's a string and a W string. As you might guess, these correspond to strings that are composed of ASCII and Unicode characters respectively. Internally, these string objects hold arrays of chars and wide chars, which are resized as needed. In our first example, we demonstrate how to initialize and output a string and a wide string. These first two lines instantiate a string object by passing a char array string literal into the constructor. Then we output the string. After this, we do the same for a wide string. Notice that we prepend wide string literals with a capital L and output them with wcout as we did before. These are the only real differences between strings and W strings. So we will focus on strings for the rest of the lesson, and you can assume that everything will work similarly for W strings. Executing the program, we see the expected output. In our second program, we demonstrate input as we did in the previous lessons. However, we remarked that when we did this with arrays, we used getLine to truncate the input to prevent the array from being overrun. With STL strings, there's no specified size, and the string will accommodate any size input without difficulty. This is a definite advantage for STL strings over arrays. In this program, we instantiate a string with the default constructor, request input, get the input, and output the string back to the console window. Now if we execute the code and enter our name, we see the same output that we had in the previous lessons, but there is no bound on the size of our input. Our third program demonstrates how to get the length of a string. We just call the length function. Executing the program, we see our string and its length outputted. For our fourth program, we demonstrate how to copy an STL string. To copy, we just use the assignment operator like this. Again, this is much easier than remembering which function performs a copy, and it has other powerful advantages that will become clear as we get further into templates. Executing the program, we see our initial string and its copy. In our fifth program, we demonstrate concatenation. We begin with our initial name string. Then we concatenate a space by calling append, and then we call append again to concatenate our lesson string to the name. Finally, we output the concatenated string. Notice again that we did not need to specify a size in our initial string, and the concatenation works without difficulty. In fact, we could append as much to this string as we like, and the STL string accommodates it. We will explain the internals later, but it is important to appreciate how much STL strings do for us. Executing the program, we see our concatenated string. Our sixth program demonstrates string comparison. As with array strings, we can call compare to tell us whether one string is less, equal, or greater than another. However, we also have the standard relational operators as well. Executing the program, we see the output of the comparisons. Our next program demonstrates how to tokenize an STL string. We begin with the string that we want to tokenize and a string of delimiters. Then we declare a start and end index for the string that we will extract. These are size type variables, which simply means that they are integers of some type. We start by calling find first of and pass in the delimiter string and the start value. This function searches the tokenized string for the first delimiter character after the index start and returns its index. So end gets set to the location of the first comma. This gives us the bounds for our first string. This while loop extracts the remaining strings. The value of npos is returned when no delimiter is found. The call to substring returns the string from start to end, which we output. Next, we assign the start to the beginning of the next string and call find first of to get the location of the end of the string. When no more delimiters exist after start, the value of endPause is returned and assigned to end, and the loop is terminated. At that point, the final call to substring extracts the last string and we output it. Executing the program, we see the tokens from the string. For our final program, we demonstrate how to get a char array from a string object. To do this, we simply call the cstring function. Here we demonstrate this by calling the function on a string and a wide string. These return a char array and a wide char array respectively. Executing the program, we see the strings outputted as expected. This concludes the lesson.